in so many previous video we have learned how to calculate probabilities over there. We have learned so many theorems of the probability, but in today's video we will discuss about the theoretical probability distribution. There is a difference between theoretical and observed frequencies over there. As we toss the coin, by theory there is a 50% chance that head will come and the 50% chance that tail will come. If suppose we are tossing a coin 50 times, so by theory 25 should be head and 25 should be tail. This is by theoretical distribution. There should be number of head is 25 and number of tail is 25. As we know that in tossing a coin, there is a equal chance of getting head and tail. So if 50 times we are tossing a coin, there may be 25 head, there may be 25 tail, but observed frequency, in observation we get 28 times we get head and 20 times we get tail. So there is a difference between theoretical probability and practically or observed probability. So in behalf of this data, we can calculate whether our coin is best or not. If some difficulty in our coin or this is a normal. So this is called the theoretical probability distribution. With the help of the theoretical probability distribution, we can having a margin difference between the theoretical probability and observed frequency. Suppose in dice, a dice we throw 36 times. We are throwing a dice 36 times. So the probability theoretical. In theoretical we are having x 1, 2, 3, 4, 5 and 6. So the probability if 36 times if we are throwing a dice, so we should be having 1 for 1 there is 6, this is also 6, chances of 6, 6, 6. It means if we throwing a dice 36 times, we should be having 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, 6 times 6, okay. But this is theoretical. And observe this was 5, this was 7, this is 6, this is 4, this is 8, this is 6. This is the theoretical probability in 36 times when we are throwing a dice. The probability of getting 1, 2, 3, 4, 5 and 6 is equally 6, 6, 6 times there should be 1, there should be 2, there should be 3, there should be 4, there should be 5 or 6. But the observed frequency is that we get 5 times 1, 7 times 2, 6 times 3, 4 times 4, 8 times 5, 6 times 6. So that is also 36. So the difference between theoretical and observed frequency, we are having that study that is called theoretical probability distribution. With the help of the theoretical probability distribution, we can having that there is a reason for the difference, or this is the by chance is over there. So we are having so many methods. With the help of these methods, we can calculate where our theoretical probability distribution is by chance or it is due to some reason is over there. Suppose we are having the dice is over there, we have learned a story of Sakuni Mama. They have the dice. In that dice he required the number is over there. So it means that dice was not normal dice. So with the help of this, we can calculate whether our coin is normal or not, whether our dice is normal or not, where our playing card is normal or not. So this is called the theoretical probability distribution. We are having three mainly methods in theoretical probability distribution. The very first is binomial distribution. We are having some more methods for getting this region. Mainly this is the first one is we are having the binomial distribution, second one is Poisson distribution, and third one is called the normal distribution. So in this chapter we will learn mainly three methods for this. First one is binomial, second one is Poisson distribution, and third one is normal distribution. So today we will learn what is binomial distribution is over there. So firstly you have learned what is theoretical distribution. Theoretical probability distribution is to get the study of difference between the theoretical probability and observed frequency, and with the help of this we can having that this is by chance or this is by a man-made or etc. is over there. So in today's video we will learn the binomial distribution. Binomial distribution, it's already we have gone through in interpolation and extrapolation. We are having the binomial expansion method. Similarly this binomial method is over there. Suppose one coin is over there. So one coin have two types, one head and tail. So the probability of head is this and probability of tail is 1 by 2. If one coin is over one coin, but two coin is over there, two coin. So head and tail, two head, there may be zero tail. If two coin is over there, there may be two head and there may be zero tail. So this is outcomes. In two coin outcome there may be two head and tail, and number of ways that is 1, that is head and head, P and P. So number of head is P square. So two coin condition is over there. What we have to learn? In two coin, if two head is over there, then 10 will 0. So number of ways, that is head and head. Suppose head is P, so there will be P square. And the probability, the number of head is this, so probability will be 1 by 4 for getting. Because in two coin, total number of event is 1 by 2 multiply 1 by 2. 2 multiply 2, so total number of event is 4. So learn, if two coin is over there, the very first you listen, I am having two coins case. Outcomes head and tail. Okay, so in two coin case the outcome may be head and tail. Number of ways, then probability, then success, and then probability. So in outcomes, if first one 2 head, tail is 0, this number of ways is 1. There may be number of ways in head in first and second also having head. So the probability is P multiply P, that will be the P square. And success is 2, so the probability is 1 by 4. Here one head and one tail, that may be also possible, one head one tail. So there may be two ways, first in head, second in tail, or first in tail, second in head. So there may be P multiply Q or Q multiply P, that is PQ, or that is also PQ. So we are having 2 PQ. So the success will be 1 and the probability will be 2 by, the probability in this case is 1 by 2, 2 by 4, that is 1 by 2. Third condition, there should be 0 head and 2 tail. It means tail in first and tail in second. So q multiply q, that is q square. So success is 0, so the probability is 1 by 4. Success is 0 in probability for head, success for head. So in two case, the very first you should learn. 2 coin is over there. We are throwing 2 coin. The outcome may be head and tail. So there may be 2 head, 0 tail. There may be 1 head, 1 tail. There may be 0 head, 2 tail. So outcome head in first and second head. So the probability P4 head, that is P square. So number of head is 2. So the probability is 1 by 4. Similarly, it may be also possible 1 head and 1 tail is over there. So it may be in 2 ways. First in first head, second tail, in first tail, in second head. So that will be PQ and QP. Both are PQ, so 2 PQ is over there. Number of head is 1 because in this also 1, in this also 1. So number of head is 1. So the probability is 2 divided by 4, that is 1 by 2. Third condition, it may be also there may be 0 head. So all 2 tail is over there. So tail in first and tail in second. So q multiply q, that is q square. So we are having the 2 coin is over there, then p square plus 2pq plus q square. If 1 is, that is p plus q. Okay. So getting head is 0. So the probability is 1 by 4. Now if we are having 3 coin, similarly I am saying 3 coin is over there. Suppose the 3 coin is over there. What we have to do? Again we learn this. Then we will having Pascal triangle or etc. If 3 coin tosses, three coins is over there. Okay. In 3 head, it means tail 0. It means first, second and third. So there will be head, there may be head, there may be head. So P multiply P, that is P cube. So success is 3. Getting 3 head. So probability of getting 3 head, that is 1 by 8. Now it may be also possible 2 head and 1 tail. In 3 coin, there may be 2 head and 1 tail. 2 head in this way, head, tail, or head, tail, head, or tail, head. This may be 3. First head, second head, in third tail. First head, second tail, third head. First tail, then head. So there will be P and Q. P, Q and P. Q, P and P, all having the P square Q. This is also P square Q. And this is also P square Q. We are having 3P square Q. Number of head is 2. So the probability is 3 upon 8. Because here the 1 is over there. So 1 by 8. Here 3 is over there. So 3 divided by 8. The outcome may be 1 head and 2 tail. So 1 head, tail, head, tail, head, tail. In this may be. Here 1 head, 2 tail. Here 1 head, 2 tail. Here also 1 head, 2 tail. We are having P, Q and Q. Q, P, Q. Okay. This is tail, head. So Q, and P. So this is PQ square. This is also PQ square. This is also PQ square. So there may be 3PQ square. Number of head is 1. So 3 upon 8, because here 3. divided by day. Here 3 divided by day. Here 1 was over there, divided by day. And last one, there may be 0 head and 3 tail. So tail, 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 that is q, 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 that is q raised to power 3. So we are having 0 head, that is 1 upon 8. So if 3 coin is over there, then this will be P3 plus 3P square Q plus 3QP square plus Q raised to power 3. If 3 number is over there, then we will having this in such kind of the condition. Okay. So in binomial distribution we will learn how to solve this. The very first you should learn how to solve this. Let me know how we can use the binomial theorem. We are having Pascal triangle. That is 1, 1, 1, 2, 1. Already we have discussed Pascal triangle. In binomial distribution, interpolation and extrapolation, the methods. 1 and 1, 1, 1 and 1, 2 and 1. 1, 1 and 2 and 2 and 1, 3, 2 and 1, 3, that is 1. 1, that is 4, 3 and 3, 4, 6, 4, 1. 1, 5, 4 and 6, 10, 6 and 4, 10, 5, 1. Then 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, then 35, then 21, then 7, then 1. Then 1, then 8, 7 plus 21. That is 28. Then 56, then 70, then 56, then 28, 7 and 1, 8, then 1. Similarly, 1, that is 9, that is 36, that is 84, that is 210, againly that is 210, that is 84, that is 36, that is 9, that is 1, and last one 1, 10, 45. $120. 294, 420, 294, 120, 45, 10 and 1. If we get the addition of this, if we will go with the addition of this 1 and 1, 2, it means 2 raised to power 1 is 2. This is the addition of 4, 2 raised to power 2, that is 4. This is the addition of 3, 3, 6, 7, 8, 8, 2 raised to power 3, that is 8. This is the addition of 16, 2 raised to power, that is 16. Now addition of this is 32, 2 raised to power 32. Now addition of this is 64. So 2 raised to power 6, that is 64. The addition of this is 128, 207, 128. The addition of this is 256. 2 raised to power 8, that is 256. This is 512. 2 or 9, that is 512. And the addition of this is 1204. 2 raised to power, that is 1024. So in this manner, the Pascal triangle can be used. The very first you learn 1, 1, then 1, 1 and 1, 2, and 1. Then 1, 2 and 1, 3, 2 and 1, 3 and 1. 1, 3 and 1, 4, 3 and 3, 6, 3 and 1, 4, 1. Againly 1, 4 and 1, 5, 4 and 6, 10, 6 and 4, 10, 4 and 1, 5 and 1. Then 1, 5 and 1, 6, 5 and 10, 15, 10 and 10, 20, 10 and 5, 15, this 6, 1. Similarly, the Pascal triangle is over there. And this is very useful. The addition of 1 and 1, 2, 1 plus 2 plus 1, that is 4, 1 plus 3 plus 3 plus 1, that is 8, 1 plus 4, 5, 5 or 10, 15 or 1, 16, 1 plus 5, 16, 16 and 16, 32. Similarly, this Pascal triangle is used. Now, we learn where we can use this Pascal triangle. That is very important to us, how we can use this Pascal triangle. Suppose we are to calculate here the addition of the Pascal triangle. If P plus Q raised to power 1 is over there, so that will be P plus Q. P value is 1, Q raised is 1. If I have the P plus Q raised to power 2, then P raised to power 2 plus 2PQ plus Q raised to power 2. So here P value 2, P value 1, P value 0, Q value 0, Q value 1, Q value 2. 1, 2, 1, 1, 2, 1. If P plus Q raised to power 3 is over there, then P3 plus 3P2Q plus 3PQ2 plus Q raised to power 3. 1, 3, 3, 1. 1, 3, 3, 1. P raised to power 3, then 2, then 1, then 0. Q raised to power 0, Q raised to power 1, Q raised to power 2, Q raised to power 3. It means the power of P will decrease and power of Q will increase. The power of P will be start with the number of square. If P plus Q raised to power 3, so the power of P will be 3. Then P2, then P1, then P0. The Q will start from 0, Q0 plus Q1 plus Q2 plus Q3. Similarly, if we want P plus Q raised to power 4, then P4 plus 4P3Q plus 6P2Q2 plus 4PQ3 plus Q raised to power 4. Here 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. P raised to power 4, then 3, then 2, then 1, then 0. Q raised to power 0, then 1, then 2, then 3, then 4. Similarly, if want to expand the Q raised to power 5, so P5 plus 5P4Q plus 10P3Q2 plus 10P2Q3 plus 5PQ4 plus Q raised to power 5. That is 1, 5, 10, 10, 5, 1. Similarly, 1, 5, 10, 10, 5, 1. This line is over there. P raised to power 4, 5, then 4, then 3, then 2, then 1, then 0. Q raised to power 0, then 1, then 2, then 3, then 4, then 5. So, in this manner, we can get the expansion of the binomial distribution. Suppose I am to calculate P plus Q raised to power 6. That is P plus Q raised to power 6. So the very first P6 plus 6P5Q. Okay. We are having another method. Firstly, keep 6. 6 5 is 30 divided by 2. 6 5 is 30 divided by 2, that is 15. Okay. So 15 P raised to power 4, Q raised to power 2. Okay. Then 15 multiplied by 4 divided by 3, that is 20. So we will having 20 P raised to power 3, Q raised to power 3. Then 20 multiplied by 3 divided by 4, that is 15. So we will write here 15 P raised to power 2, Q raised to power 4. So 15 power 2, so 15 multiply 2 divided by 15 divided by 5, that is 6. So we will having 6 p raised to power 1 q raised to power 5. And last 6 multiply 1 upon 6, that is 1. So we are having q raised to power 6. Again we are having 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. Okay, the second method. 5, 6, 5 ja, 6 multiply 5 divided by 2, that is 15. 15 multiply by 4 divided by 3, that is 20. 20 multiply by 3 divided by 4, that is 15. 15 multiply by 2 divided by 5, that is 6. 6 multiply 1 divided by 6. Firstly, we are dividing with 2, then 3, then 4, then 5, then 6. So this is also a method for expensing binomial distribution. So we are P6, then 5, then 4, then 3, then 2, then 1, then 0, Q0, then Q1, then Q2, Q3, Q4. One more expansion with this method, so you may be learn how to calculate this. Suppose I am to having the expansion of P plus Q raised to power 8. P plus Q raised to power 8. This will. And last we will having the 10 for also. So that you may learn. Okay. This will be. So very first one, that is P8. Okay. So 8 divided 1, that is 8. So that is 8 P7Q. Okay. So 8 multiply 7 by 2, that is 28. So that is 28 P raised to power 6 Q raised to power 2. 28 multiply by 6 divided by 3, that is 56. So we are having 56 P raised to power 4 Q raised to power, now P raised to power 5 Q raised to power 3. 8, 7, 6, 5. Now 56 multiply by 5 divided by 4. So we are having 56 multiply by 5 divided by 4, that is 70. So we are having 70 P raised to power 4 Q raised to power 4. Now 70 multiply by 4 divided by 5. That is 56. So having 56 P raised to power 3 Q raised to power 5. Then 56 multiply by 3 divided by 6. That is 28. So 28 P raised to power 2 Q raised to power 6. Then 28 multiply by 2 divided by 7, that is 8. So last one 8 P raised to power 1 Q raised to power 7. So 8 multiply 1 divided by 8, that is 1. So Q raised to power 8. So in this manner also we can having the expansion of binomial distribution, that is 1, 8, 28, 56, 70, 56, 28, 8, 1. 1, 8, 8, 28, 28, 56, 56, then 70, then 70, then 56, then 56, then 28, then 28, then 8, then 8, then 1. So in this manner, the very first 8 multiply 1 by 8, then 8 multiply 7 divided by 2, then 28 multiply 6 divided by 3, then 56 multiply 5 divided by 4, then 70 multiply 4 divided by 5, then 56 multiply by 3 divided by 6, 28 multiply by 2 divided by 7, 8 multiply by 1 divided by 8. In this manner we can having solve. Last one we are having. So it's very important. Binomial expansion is very important. So many times I am teaching this. Now we are coming on this. Suppose we have given P plus Q raised to power 10. So the very first P raised to power 10. Okay. So 10 multiply 1 divided by 1, that is 10. So having 10 P raised to power 9 Q raised to power 1. Okay. So 10 multiplied by 9 divided by 2, that is 45. So we are having 45 p raised to power 8 q raised to power 2. Then 45 multiplied by 8 divided by 3, that 120. So that is 120 p raised to power 7 q raised to power 3. So 120 multiplied by 7 divided by 4, that is 210. Some difference is over there. 36 plus 84, 84 plus 210. 120 multiplied by 7 divided by 4. Okay. 120 multiplied by 7 divided by 4, that is 210. So here some difference is over there. 9 and 1 10, 9 plus 36 46, 36 plus 84 120, 84 plus some difference here is over there. Okay, that is 6 1 2. Sorry, 1 9 36 28 plus 56 84. Okay, 56 plus 70, that is 126. 70 plus 56, that is 126. Okay, so there was the difference. So here also the difference will over there. 84 plus 126, 210, 256, 252, 210, then 120, then 45. Okay, no problem at all. Now 120 multiplied by 7 divided by, that is 210. So we are having 210 p raised to power 6 q raised to power 4. Then 210 multiplied by 6 divided by 5. 210 multiplied by 6 divided by 5, that is 252. 252. So there will be 252 p raised to power 5 and q raised to power also 5. So 252 multiplied by 5 divided by 6, that is 210. So here I have 210 p raised to power 4 q raised to power 6. Now 210 multiplied by 4 divided by 7. So 120. So we are having 120 p raised to power 3 q raised to power 7. Then 120 multiplied by 3 divided by 8. So that is 45. So 45 p raised to power 2 q raised to power 8. Againly 45 multiplied 2 divided by 9, that is 10. P raised to power 1 q raised to power 9. So that is 10 multiply 1 upon 10, that is 1. So that is q raised to power 10. So in this manner we can having the expansion of binomial distribution, or we can say this is the expansion of binomial distribution. Now this is 1 10 45 120 210 252 210 120, this one. So in this manner we can having the expansion of binomial distribution. So we are having the first method, that is called binomial distribution, and the formula for the binomial distribution is this, like n p plus q raised to power n. And capital N is number of repetition. N is number of coins. P is probability. of success and Q is probability of unsuccess. So with the help of this is the formula for the binomial distribution, and how we can open this P plus Q raised to power n, we have discussed in very detail. So I think with the help of this video, you maybe learn how to simplify the binomial distribution over there. In our next video, we will learn how to solve the problems of the binomial distribution. Thank you once again.